how to find error intervals for truncated decimals in 91 seconds. Let's go. This is a topic, guys, which doesn't come up too often in exams. However, when it does, not many people get it right at all. Let's have a look at this one. The question says a number is truncated to one decimal place and becomes 4.7. We're asked to write down the error interval. The error interval, guys, is going to describe the different possible values that our number could have taken before it was truncated. We're going to call our number x, and we're going to have a less than or equal to sign here and a less than sign here. Now, what are our values going to be? The smallest possible value that x could have been before it was truncated is going to be 4.7. Why is that? That's because that's going to be the smallest possible number that when we chop off every single number after the 7 would give us 4.7. Try and wrap your head around that, guys. It's a little bit tricky. Now, what about on the right-hand side? What are we going to have? If we think about it, the largest possible number that x could have been before it was truncated would essentially be 4.7. 99999 reoccurring. That would go on forever. Why? Because this is the number which is the largest possible number that when we chop off the values after the 7 would give us 4.7. In reality, it's not very practical to write 4.79999 reoccurring. So instead we use a less than sign instead of a less than or equal to sign to signify the fact that it's going to have to be less than 4.8. Now, the quickest way to think about this, guys, is simply going to be that the smallest possible value is going to be exactly the number that it was truncated to, and the largest possible value, to get that, we're just going to add 1 to the degree of accuracy that we rounded to.